So here's a wild question for you. How do you test the entire internet? I mean, really think about that. Every single app, every button, every little interaction. It sounds completely impossible, doesn't it? Well, for the people who actually build our modern web, this isn't just some crazy thought experiment. It's their daily challenge. All right, let's get into it. Today, we are going to pull back the curtain on modern web testing. We're going on a journey that starts with just a single line of code and ends up in the massive cloud systems that pretty much run our entire digital world.
All right, here's the plan. First, we're going to look at the absolute fundamentals, the skeleton of a web page. Then, we'll peek behind the scenes and see how apps actually talk to each other. After that, we'll meet a super powerful tool called Playwright, figure out how to build tests that can actually scale, and finally, we're going to see what happens when we push these things to their absolute breaking point.
Okay, first things first. If you're going to test a web app, you have to understand its anatomy. I mean, what is a web page really made of? It all comes down to three core components.
Everything, and I mean everything, starts with HTML. The best way to think about this is like a skeleton. It's not pretty on its own, but it gives everything its fundamental structure. You know, every heading, every paragraph, every image you see, it's all defined by an HTML element.
So once we have the skeleton, we need to add the style. That's where CSS comes in. If HTML is the skeleton, you can think of CSS as the skin, the clothes, the whole personality of the site. It controls all the visuals, the colors, the fonts, the spacing, basically everything that makes a website look good instead of, a total mess. And this right here is where the magic happens, the DOM. It basically brings the page to life. Think of it like a live, interactive blueprint of all that HTML. It's what allows a programming language like JavaScript to find any little piece of the page, a button, a form, whatever, and change it instantly. You ever click a like button and watch the icon change color without the whole page reloading? Yep, that's the DOM at work.
You know, when we look at a web page, we see text and images and stuff, but a browser, it sees something totally different. It just sees boxes. Literally every single thing on the page is a rectangle, and the CSS box model is the rulebook for how they're all arranged. Understanding this, that every element has its content, then some padding inside, a border around it, and a margin outside, is absolutely crucial for anyone trying to test a user interface. Okay, so we've got our web page built, but where does it get its information? How does your social media feed load new posts? How does your shopping cart know what's in it? Well, that all happens thanks to the secret messengers of the internet, APIs. This is honestly the perfect way to think about an API, or an application programming interface. You, sitting at your computer, are the customer. The website server, that's the kitchen. The API is the waiter. You don't go into the kitchen yourself, right? No, you tell the waiter what you want, the waiter goes and tells the kitchen, and then brings back exactly what you ordered. It's the perfect middleman.
So how do those orders actually get placed? Well, it pretty much boils down to these four basic operations, which we call CRUD. If you want to create new data, like making a new post, the app uses a POST request. If you want to read data, like loading that feed, it uses GET. To update something, like editing one of your comments, it uses PUT or PATCH. And to delete it, well, you guessed it, it uses DELETE. This is the fundamental language that all applications use to talk to each other.
All right, so we've got this complex web of user interface elements and all these behind-the-scenes API calls. How in the world do we test it all efficiently? Well, let's meet our inspector for the job, a really cool, modern framework called Playwright. So Playwright was developed by Microsoft back in 2020, which means it was designed specifically for the modern web we have today. See, a lot of the older tools, they really struggled with today's super dynamic, always changing applications. Playwright was built from the ground up to handle all of that complexity like it's no big deal.
So why do so many developers love it? Well, there are a few huge reasons. First, cross-browser support. You write one script, and it can test your site on Chrome, Firefox, and even Safari's engine, WebKit. Second, it has this auto-wait feature, which solves a massive headache that older tools used to cause. And third, and this is a big one, it combines UI and API testing into one single framework. That's a total game changer for efficiency.
And that right there is its biggest advantage. When you put it side by side with a great API-only tool like Postman, Playwright's main benefit just shines through. It's a unified tool, a one-stop shop. You don't need one tool for what the user sees and another for the data calls in the background. It simplifies the whole process and lets you plug your tests right into your development pipeline.
Now, look, having a great tool is one thing, but using it the right way is something else entirely. As your application gets bigger and more complex, you need a blueprint, a plan, to organize your tests so they don't turn into a complete, unmanageable mess.
And that's where the Page Object Model, or POM, comes in. This is a professional design pattern, a real strategy. The idea itself is actually pretty simple, but it's incredibly powerful. For every single page in your app, say the login page or the dashboard page, you create one matching file of code, and that file holds all the ways you can interact with that specific page.
So why would you bother doing all that? Well, imagine the login button on your website changes. Without this POM structure, you might have to dig through dozens, maybe hundreds of different test files to update it everywhere. But with POM, you change it in one single place, the login page file. That's it. It makes your tests way more maintainable, easier to read, and reusable. It's a clean separation of what you're testing from how you're testing it.
And this is what that clean separation actually looks like. See? You've got one folder for your pages. Those are the objects that know how to click the buttons and fill in the forms. And then you have a totally separate folder for your tests, which just call on those objects to get the job done. It's a super clean, organized, and scalable blueprint for all your automation.
Okay, so our app works, the buttons click, the data shows up. We're good, right? Well, what happens when 1,000 people try to use it at the same time? Or 1,000,000? Now we have to go beyond just asking, does it work, and start testing under pressure.
And to do that, you need to know two really important acronyms. The first is SLA, the Service Level Agreement. That's your external promise to your customers. For example, promising that your site will have 99.9% uptime. The second is the SLO, or Service Level Objective. That's your internal goal. And here's the key. Your internal goal always needs to be stricter than your public promise. Because if you're only aiming for the promise, you're going to miss it sooner or later. To make sure they hit those goals, engineers run a bunch of different performance tests. A load test just checks that the site can handle its normal, everyday traffic. A stress test is designed to push the system until it actually breaks, just to find out where that breaking point is. A soak test runs for a long time, hours, even days, to find sneaky problems like memory leaks. And a spike test simulates a huge, sudden rush of traffic, like when tickets for a massive concert go on sale. Each one answers a different but critical question.
So we've gone from the basic building blocks of HTML all the way to these incredibly complex performance models. It's clear that testing has become this deeply technical, highly automated field. And that leaves us with a really fascinating question to think about. In a world of total automation, as our tools get smarter and smarter, what's the role for human insight? What can curiosity and empathy and just plain old intuition bring to the table that a script never, ever will?